Property number 3 of rectangles states that two diagonals are congruent. So two congruent diagonals. So on the back side, we are going to be looking at examples number 5 and number 6. So there are properties from parallelograms that we have to remember. As a parallelogram, diagonals bisect each other. So since diagonals bisect each other, I'm going to start with example number 6. Excuse me, I'm going to start with example number 5. I am ahead of myself. We have segments, diagonals, AC. And we have diagonal BD. These two diagonals are here. They are congruent. So therefore, since they're congruent, using the property of reason number 3. So what I'm going to do is I'm going to say AC is equal to BD. And then I'm going to substitute in their given values, expressions. 4x minus 54 equals 33 plus 1x. So minus x plus 54 plus 54. 3x equals 87. Divide by 3. Rounding up, x equals 17.4 in my calculator, so round up. Nope. Does not equal 17.4. Let me go double check that. This is what happens when I use an answer key. $87 divided by 3 is actually 29. I apologize for that. So find x and then find BD. So what I'm going to do is I'm going to plug that back into BD. So BD equals 33 plus x, or 1x, which equals 33 plus 29, which equals out to be 62. So BD equals 62. Once again, I apologize for that error. The other form of properties with diagonals being congruent and properties with diagonals from parallelograms is that they bisect each other. So we are given AC again. So AC is equal to this segment here. Okay. And then we have DE here. So since diagonals are congruent in the measurements, if I cut AC in half, or excuse me, AC in half, EC would be equal to the measurement of AE. But since these distances are congruent, the segments that form the diagonals, the half segments or part of the segment, is going to be congruent. So the measurements are all going to be the same here, here, and here. Because if the diagonals are congruent and then they're cut in half because diagonals bisect each other, then all the halves are going to be congruent. So, given the information that we have, we're using reason 3 about diagonals being congruent, and then we are using from parallelograms about diagonals bisecting each other. So AC is actually equal to 2 of DE, just like from the parallelogram example. You may have DE, or the half, equal to 1/2 of AC, the total diagonal. So with that, 4x minus 60 equals 2 times x plus 5. 4x minus 60 equals 2x plus 10 with distribution. Minus 2x minus 2x plus 60 plus 60. 3x equals, 2x equals 70. Divide by 2. X equals 35. And it wants to find the measurement of EC, and as I said, all these halves are congruent, so EC is equal to DE. So EC is equal to x plus 5. EC equals 35 plus 5, which equals 40.